welcome to Math with Taebyn. My name is Taebyn. I'm a pup, bark bark, and I would like to do some more math with you. I would like to talk in this particular video about a very interesting theorem called the Color Theorem. I'll tell you a little bit history about it in a little bit, but let me tell you what it is first. So define a map just to be a whole bunch of geometric shapes all just glued together. For example, the map of the United States, like this. Or a map of just a bunch of random geometric shapes, like this. Okay, so now what is the question is, how many, like you can color the map. So let me just give you an example, I guess. So I'll just draw a very simple map. Maybe like that. We want to be able to color the map. That is, color in each shape with a different color so that no two shapes are colored the same thing. So, for example, I could color this pink, but I don't want to color this pink also, because then they'd be next to each other. So instead, I could maybe color it red. Whoa! That's a color. Okay, well, that was fun and exciting. Well, it's even more fun and exciting. You could, for example, then maybe do that. Can't be pink, but it could be red. Or it could be some other color, like blue, maybe. But let me use red. Again. Whoa! But what I could have done, instead of drawing it here, I could have drawn it right here. Now I cannot use pink or red. I have to use a different color, like blue. So I needed 3 colors to color this map, and so that no two adjacent geometric shapes are the same color. Now the question is, given any map, what is the smallest number of colors that you would need to do this type of thing? So let me do another example. So here's just a bunch of shapes together. And as I said, so the fourth color theorem wants to know what is the least number of colors needed so that no two adjacent shapes have the same color. And this goes for any map. Is there a smallest number? So let's try and do it just with this. So first, I could take one color and I'll just color in. I'll just try. How about this? Okay. And then if I do that, if I wanted to color in this shape, it needs to be a different color. I would need a different color up here. It can't be red or blue. Then I could color maybe this one. I could color this pink again. Okay. And then all I could do, this one would have to be blue. So I can do this with 3 colors so far, so that's great. I'm not quite done though. Now this one cannot be blue or pink, so let's choose red. I'm so good at coloring. So then what about this one? Well, it can't be red, pink, or blue. What do? We have to do a 4th color. So we would need 4 colors to color this map. Now, it's possible, maybe I just chose the wrong colors. Maybe it's possible to do it with 3. You need a bunch of colors. So then, what about, say, for any map, like the US map, how many colors do you need? Or the other map that I showed you? Well, the 4-color theorem says that for any map, you need at most 4 colors. At most 4 colors. So in other words, this is kind of the worst case scenario right here, in a way. Now, this is a really interesting theorem, and it took people many years to figure it out. This question was first posed in 1852. 1852, wow, long time ago. And people worked on it, and as simple as it seems, and try for yourself, it seems that, oh yeah, it's obvious, but to prove it, people couldn't do it back then. In fact, it wasn't until the 60s and 70s that people used computers to try and prove it. And it wasn't until 1976 that it was actually proved And it actually wasn't a direct exhaustive proof. Like, they didn't use computers to like try all the possibilities, because that's way too many. It was actually a proof by contradiction. But it took over a century for them to prove something as simple as this. Very interesting, right? Right. And you get to use all these colors. So this is very interesting and cool. If you're interested in reading more about it, you can go to Wikipedia and just search for the Color Theorem, and you can read more about it. And there's a generalization of this called the Hadwiger conjecture that is still actually not proven yet. So there's still open questions and things and fun, cool stuff. Isn't it, Meek? Yes, it is. Everyone say yay! Yay! So on that note, I'll see you next time on Math with Taebyn. Bark, bark.